Let me discuss about resultant force. If a number of forces acting on a particle simultaneously are replaced by a single force, which could produce the same effect as produced by a given forces, that single force is called resultant force. If they given a same effect of as produced by the given forces, for example, they given the given forces, we convert it into a single force. We want to know the symbols of to identify the resultant force. Upward vertical force is positive, downward vertical force is negative, and then horizontal force acting from the left to right positive, and then horizontal force acting from right to left negative. We know the symbols of identify the resultant forces. For example, find the resultant forces of the collinear forces. They given the single line of forces. We want to find the resultant force of the collinear forces. We want to know we want to see the where the direction will go. The direction is horizontal force acting from right to left is negative. The force is acting negative. So first we want to draw again solution again like this: 8 Newton, 10 Newton and 12 Newton. We know the direction horizontal force acting from right to left is negative. So we want to put minus 8, minus 10, minus 12. Let's minus 8, minus 10, minus 12. We get the answer is minus 30. We want to draw the force is single force in negative direction. We get the answer is 30. Then another example. Example number 2. Find the resultant force, the collinear force. As we were saying, it changing the directions here, here and here. Here the resultant force, the force is horizontal force acting from the left to right positive to, then here horizontal force acting from the right to left, so negative, then here and positive, here negative. 2 minus 3 plus 6 minus 11. We get the answer is minus 6. We want to draw as same. Here we get the answer is in the symbol of minus. So we want to put horizontal force acting from the right to left is negative direction. So minus 6. Then resultant force. Using the parallelogram law of forces, it states that if two forces acting simultaneously at a point be represented in magnitude and direction by the two adjacent sides of parallelogram, then the resultant force of these two forces is represented in magnitude and direction by the diagonal of that parallelogram originating from the point. We want to solve the theorem of parallelogram. So we get the formula of resultant force: root p square plus q square plus 2pq cos theta. Let me see the example sum from parallelogram using the result. How to find the resultant force. Example number 1. Two concurrent forces of 12 Newton and 18 Newton are acting at an angle of 60 degree. Find the resultant force. The given solution, given data, let's draw p q. We don't know the resultant force. R equal to, they gave 12 Newton and q is 18 Newton. We don't know the resultant force. P equal to 12 Newton, then q equal to 18 Newton. They gave theta value is 60 degree. We don't know the alpha value. We know the resultant force formula. R equal to root p square plus q square plus 2pq cos theta. We know the value of p, 12 square plus 18 square plus 2. P value is 12 into q value is 18, cos theta value is 60 degree. Let we simplify this. We get the answer is We get the answer is 26.15 Newton. And then we want to find the inclination of resultant force. Force of P. The formula is tan alpha equal to Q sine theta plus P plus sine Q sine theta. If we know the value of Q value, 18 sine theta is 60 degree, P is 12, Q is 18, cos theta 60. We get the answer is 18 sine 60 degree divided by 12 plus 18 cos 60 degree. We get the answer is 0.742. Then we converted into alpha value equal to tan inverse the value of Q sine plus P plus Q is 0.742. We get the alpha value is tan inverse 0.742. 36 degree 34 minutes. We get the value of both resultant force and alpha value, 36 degree and 34 minutes. And then resultant force value is 26.1.